And on to our next rule, we'll take a look at negative exponents. Let's take a look at an example. 5 to the power of negative 3. So when we've seen powers before, that exponent represents the amount of times we multiply the base. So how do we multiply 5 negative 3 number of times? We can't. In fact, that doesn't make sense. We can't multiply something a negative amount of times. That's like asking, how many times have you gone to the store? And you answered, negative 3. That doesn't work. Instead, that negative in front of the exponent represents not how many times we multiply the base, but how many times we divide by that base. In fact, how many times we divide the number 1 by that base. So let's take a look. 5 to the power of negative 3 will actually represent 1 divided by 5, that's our first time, divided by 5, second, divided by 5. Notice we've divided by 5 3 times. There's another way of writing this, though. Remember back in middle school that complex fractions can, instead of all these divisions happening, be written as multiple multiplications. So I can convert this to 1/5 times 1/5 times 1/5. And now we simplify by multiplying our numerators and denominators. So we get 1 over 5 times 5 times 5. You'll note I didn't actually do the multiplication yet. And here's why. Because our denominator can be rewritten as a power. And we end up with 1 over 5 to the power of 3. Notice that from the beginning to the end of this problem, they look very similar. Let's take a look at another example. 1/2 to the power of negative 3. Again, that means we take the number 1 and we divide by 1/2 3 times. But these complex fractions get really hard to deal with. So instead of thinking about the division by these numbers, let's think about the multiplication of the reciprocal, because that's what complex fractions convert to. So we're going to take the reciprocal of 1/2. Remember that reciprocals are just fractions where the numerator and denominator have flipped. So we are going to take 2 over 1 times 2 over 1 times 2 over 1. And we'll multiply this out. And we get 2 to the power of 3 over 1. Or simply put, 2 to the power of 3. Again, notice how similar our beginning and end look. Let's take a look at our actual rule. In general, if we have a power with a negative exponent, m, negative m, it's the same as the reciprocal of that power to a positive exponent. Let's take a look at one of our previous examples. Instead of doing all this work, just using the rule, all we have to do is find the reciprocal and make sure that denominator is a positive exponent. So the reciprocal of 1/2 is 2 over 1. And now we have a positive exponent. I'm going to simplify once more to make it look nice and neat. And we get the same answer. Again, our rule states that a negative exponent represents the reciprocal of the base to that power being positive.